Okay, in this video we're going to talk about classes and objects in C#. We're going to talk about what they are, why we use them. They are a very, very important part of C# and object-oriented programming in general. So we're going to talk about what's the idea behind them. Why do we use classes? What are they? What's the concept here? And to do so, we're going to talk about modeling a real-world object. In this case, it will be a motorcycle. So why would we want to model a motorcycle in C#? Well, let's say you have a job to do, and that is to develop a motorcycle racing simulator in C#. So here you've got a stationary motorcycle and a rider, and he's interacting with this simulator written in C#, and he's basically adjusting the controls, and your simulator has to respond as if he's driving through the streets. So the question is, how am I going to just start to develop code to model this motorcycle and how it acts and how to simulate it so your simulator will work? Well, the first thing you can do is the obvious thing, and you can start looking at the motorcycle and making a list of all the characteristics and specifications. Basically what I call the passive characteristics of the motorcycle. It's got a color, it's got a size, it's got two wheels, it's got a specification for engine horsepower, top speed, weight, fuel capacity, manufacturer, does it have electronic ignition? So there's a lot of very just passive things that don't generally change that are inherent to this motorcycle. And those are kind of the characteristics and specifications. Now there's also a bit more active things that are characteristics, but you can change them. They are settings. For example, you can set the carburetor, you can adjust the carburetor, you can adjust the brakes. So there are some characteristics that you can actually change, and those are also parts of this motorcycle that you will probably need to simulate. Now, another category of item is the actual functionality of this motorcycle, the driving, what it takes to make this thing drive. You've got controls, steering, accelerator, brakes, lights, signals, ignition. A lot of the functionality that without it, you couldn't drive the motorcycle. You've got the engines and controls and all the critical part that you need to simulate somehow, all the functionality of this motorcycle so that you can simulate it in software. Now, the third category is the real-time stuff that happens while you're driving the motorcycle. For example, maybe the engine overheats, or the turn signal operates, or you shift the gears, or the brakes are applied, the handlebars are turned, the throttle is twisted. All of those things go into controlling the motorcycle, and they are all things or events that happen as you are driving the motorcycle. So to really model this motorcycle completely, you need pretty much three categories: the passive characteristics and specifications, including the kind of active settings, which may or may not be active. And then you've got the controls, the functionalities, the methods that this thing uses to drive, and then the real-time stuff that happens as you're driving. In C#, you've got all those things, but they are given different terminology. The characteristics and specifications and settings are called properties or fields. And we'll talk about the difference between those two coming up. And the controls and functionality are called functions or methods. That's all the steering, accelerator, brakes, the functions that are performed. And then the real-time stuff that happens are called events. So when you're talking about C#, you're talking about the methodology of properties, fields, functions, methods, and events to fully describe this motorcycle. Now, I want to talk briefly about the difference between properties and fields. As I said, there's a bunch of characteristics and specifications of this motorcycle that are passive. They don't really change. Those are called fields in C#. Now, there is also a setting, an adjustable active characteristic, such as, in this case, the carburetor has an adjustment. Okay, on a motorcycle, anybody can walk up with a screwdriver, and there's a screw externally available to anybody that you can adjust the carburetor setting to adjust how much air and fuel goes into the engine. That is, in C# terminology, a property. It is kind of an active setting that you can get In other words, you can look at this screw and see the current setting position, and you can set it. You can take a screwdriver and you can go up to it and you can set it. So an active setting that you can get or set that is available to the public is called a property. A passive, generally not non-settable characteristic is called a field. So there's properties and fields, and they're a little bit different in C#. So now that we've defined all of these categories and all of these types of things we need to describe this motorcycle, we can go into our C# code, into Visual Studio, and we can start listing out all of those things. So here I've got comments here showing the properties, the methods, and the events that we just talked about. So if you want to simulate the motorcycle in C#, you will start writing out the properties. You've got a color, red or orange, so you can maybe get a string, red and orange. You got wheels, how many wheels, the top speed, all those specifications. And then you've got the setting, the property of the carburetor adjustment. You can define all those, so you write out all the code to define those. And then you've got the methods, the functionality, the stuff that actually drives the motorcycle. So here you've got the accelerator, and you've got to write code to simulate how that accelerator works. So for example, you twist the grip on the handlebar, that can rotate from 0 to 90 degrees. And when that rotates, it pulls a cable that goes to the throttle carburetor, and that moves by 0 to 1 inches. That opens the throttle, which adds or subtracts air and fuel into the engine. And then you can define a graph of throttle position versus engine load to tell you what the speed is. So you define all these lines of code. It might be hundreds of lines of code to define how this accelerator works. And then the brakes, same thing. The foot pedal is depressed from 0 to 4 inches, and that pulls a cable connected to the mechanical disc brake, and that causes the brakes to operate. And then you can do the same thing for steering. And then you can write out the events. For example, the engine overheats, and that heat sensor sends a signal to the alarm display on the front panel, and so on. So to fully describe this motorcycle with all of these characteristics and methods and events, you write out all these lines of code, and you may have hundreds of lines of code. And when you're done with that, you have successfully, hopefully, described the motorcycle in enough detail that you can actually simulate it. So let's say you write out these hundreds of lines of code and you give it to your boss. And your boss says, hey, that's great, but I forgot to mention, I want you to also simulate these 5 other motorcycles. So you say, oh my goodness, what am I going to do? I just wrote all these hundreds of lines of code to describe this one motorcycle. Now I got to copy and paste it 5 more times and change all the specifics to match these new motorcycles. Wow, that's going to be a lot of work. Or you can step back and say, now wait a minute. All of these motorcycles have common properties and methods and functions and events, right? They're motorcycles. They all have engines. They all have steering. They all have brakes. They all have accelerators. They all have 2 wheels. They all have fuel systems, okay? A lot of the events are the same, right? You get engine overheating. You get speedometer indication. So all of these motorcycles have a lot of commonality, a lot of common methods, functions, properties, and events that really, if you can describe them once, you can apply them to each of these different motorcycles. You might have to make some changes, like the colors are different, some of the specifications are different, and maybe the way they do things are different. One might have an electronic ignition, one might have a mechanical. You press on a bar and it starts the motorcycle. So, but if you're smart, you can think about how all of these motorcycles belong to a class or a definition of a motorcycle. And if you can gather all those common methods, properties, and events into one block of code, then you can just copy a lot of that for each of the individual motorcycles and just make a few changes for your individual motorcycle. But really just write the code once and borrow it each time you need to make a new motorcycle. That is called a classification of motorcycle. It basically defines that a motorcycle includes an engine, steering, accelerator, brakes, fuel supply, and basic functionality, And every motorcycle needs to have that, or else it's not a motorcycle. Now, the designers of C# saw that that type of classification happens a lot in the real world. You've got a lot of objects that fall under a general classification. They may be a little bit different, but they all fall under a general classification. So you can define that definition or classification of a general object and just use it for each individual object that you're actually simulating. That is called in C# a class, or an object-oriented program, where you treat things as a class of a generic object. And in C# we can define a motorcycle class that defines what is common to all motorcycles. And it's basically a block of code called a class. And here we've got a motorcycle class that has properties and fields, methods or functionality, and events. Okay? So that is basically a class, and it is a very, very powerful concept in object-oriented programming in C# that you can define this general basic definition of what a motorcycle looks like and then apply it to each individual motorcycle that you develop in your code, your simulation. Now, again, you can apply this concept to all types of things in this world. A vehicle, a person, an airplane, a computer, a traffic light, a supermarket, a program, a refrigerator, a production line, a warehouse. Basically, these are all definitions of what a supermarket includes, what a program or what a refrigerator includes. They all do similar things, but they're a little bit different. So all of these are definitions. They're not the actual objects. They are kind of a dictionary definition. You'll also hear people refer to them as blueprints. Basically a definition of what that object does and what the properties and methods are. And you can build that code in one box and then use it for every individual object. So a class is different from an object. For example, you don't own motorcycle, right? Motorcycle is a definition, a dictionary definition of a class or a type of object, right? You can look up in a dictionary definition of motorcycle and says it's got two wheels, it's got an engine, it's got steering, blah, blah, blah. You don't own motorcycle, you own a particular motorcycle. So that is the difference between a class and an object. A motorcycle is a class or definition. This particular motorcycle, this racing bike, is a particular motorcycle that you can own. So you've got a motorcycle class, which is a definition of common characteristics of a group, and then you've got a specific object in that group. So you've got a class, and in C# terminology, you've got an instance of the class, also called an object. Okay, so you define it, and then in your code, you actually make one that has specific properties, specific functionality, and specific events. So in general, a class provides a pre-made framework of code that you can use to make your own individual object without reinventing the wheel each time. They are reusable blocks of code. You must make an instance of the class in order to use it, right? You don't use a dictionary definition, you make an actual object. So you must make your own object from that class. So now that we know what it is and where it comes from and why we might want to use it, let's go into Visual Studio and let's see if we can start developing some code to actually define a motorcycle and how we would do it if we were writing out a motorcycle racing simulator. So here I've got a general Visual Studio console application, and you can see here it starts out with my namespace is motorcycle. Here's my program class and my static void main, the entry point. This is what you normally get when you start a console application. Now what I've done here is I have added a class. Now here it just says class, motorcycle class, and I've got two curly braces. So class basically defines that I'm making a class. So that keyword class is used to say, okay, here's a class, and motorcycle class is the name of the class that I've given it. I gave it the name motorcycle class. And I've got two curly brackets to define everything inside those curly brackets is my class. Okay, so I've taken what we defined before, the properties and fields, all the types of properties and fields, the methods, the accelerator, the brakes, the steering, and the events. So these things, I need to start writing code to define them as my class of object. And once I've got them defined, I can borrow those for my specific object or instance that I make from this class. So let's start with properties and fields. Now in Visual Studio, there is a code snippet, prop, and if you use that, it will lay out the basic structure of a property. Now, I said here that the property we're going to use is this carburetor adjustment, okay? And we said it's basically a screw that you can look at the setting on the carburetor adjustment screw, and you can set it. You can go in and take a screwdriver and set it. So if we're going to model that property, let's call it we'll call it carburetor adjustment. Now we also said that this is a public property. Anybody can go in and set that. So it's externally available, that carburetor adjustment. So we've got a public property, carburetor adjustment, and it's got get and set functionality. So basically you can use this to get the existing setting or set it, make a new setting, okay? That is the basic idea behind a property. Now we can also define a field. So let's say string, and we're going to have a field color. Okay, so in doing these properties and fields, you would lay them out just like this. We'd have a property, and we can add other properties, and then we would have fields. So for each of these, we can start listing those, and they would all belong to the motorcycle class. So that gives you a brief explanation of properties and fields and how you lay them out in C#. Now the next thing you can do is start defining some methods, like your accelerator, your brakes, your steering. Those methods, I've got a code snippet that I developed in Visual Studio, and the basic format of this is, here's a method, and let's call this accelerator. Okay, now the method basically can take a value, which might be double grip position. So you might take in the position of the handle grip, and there it would do all of this code where it would convert that handlebar grip position into a new speed on the motorcycle, okay? And you can do that for all the other methods. We did the accelerator, we can do the brake, we can do the steering, whatever. So here we've got properties, fields, methods. We can also do events. Now I'm not going to talk about events. We went through events and delegates in the previous series of videos, so you can look at those. But I think you get the idea. You're starting to lay out all of the motorcycle class properties, methods, and events. And once you've got that, now you can go, and I said that's a definition. Now you can make an actual motorcycle. So motorcycle class, and we'll call it racing bike, equals new motorcycle class. Okay, so now we have made an instance or an object from this definition. Okay, so now racing bike dot, and here we can see you've got a carburetor adjustment property. Okay, so it recognizes our carburetor adjustment property. We've got an accelerator method with this little box thing. We've got this accelerator. And as we start adding, we will get more properties and methods that we can start using now. So hopefully that's a general overview on what a class is. And I hope it's helped to erase any mystery around what classes and objects are. So take care. Have a good day.